Hey guys, we are going to do some factoring today for you semester 2 folks. So the two things we're going to be doing is solve an equation that is already written in its factored form. You've already seen some questions like this, and then the second type you've also seen as well. We're just doing more practice on both, is solving a quadratic by factoring. So check it out. This first one here, you'll notice it's already in its factored form. You've got 4u plus 5 all multiplied by 9 plus u, and that's set equal to 0. We're trying to solve that so that we're going to actually get two solutions here. So you'll notice that it says if there's more than one solution, separate them with commas, and we're just about to do that, okay? So it's actually pretty easy to do this. What we're going to do is let each of these terms in parentheses be equal to 0 and then solve for the variable. That's all you have to do. It's surprisingly simple to do once it's in this factored form, and for these first ones, they've already set it up for us nicely. So first we'll take 4u plus 5 and set it equal to 0. And you guys know how to do this. This is just a simple two-step equation. We'll subtract 5 from both sides and then divide both sides by 4. Our answer here, this is as simplified as it gets. U is negative 4 over 5. On this side, we set this term equal to 0. So that's 9 plus u equals 0. So that's u equals negative 9. And that's it. So what you'd actually type into ALEKS, here are our solutions. In ALEKS, you type it in like this. You'd go negative 9, comma, negative 5 over 4. To be clear, it doesn't matter which order you type them in. It should accept the answer either way. All right, let's have you try this. I'll go ahead and pause the video. See if you can find the two solutions for this equation. All right, hopefully you've had a chance to work that out on your paper. So remember, we set both of them equal to 0. On this side, we have 3b minus 2 equals 0. Solving that for u, we get 2/3. On this side, very similar, b minus 6. Add 6 to both sides, get u equals 6. And again, you're going to type into ALEKS 2/3 and 6. Those are our two solutions. All right, so we got that our answers were x equals 2/3 and x equals 6, or whatever variable we used. It doesn't really matter. What I want to show you on this graph is what we're actually doing, which is we're trying to find the zeros, or where this parabola, that's the shape of this funny looking thing here, where it crosses the x-axis. So those 2 points represent the solutions to this parabola. So our answers from before, when we set this equal to 0 each term, were x equals 6 and x equals 2/3. So 2/3 in decimal form is 0.6 repeating. Let's double check this one. Yep, we get 0.6 repeating. It's just rounding there to get that 7. And then the other one we said should be x equals 6, and there you go. It is x equals 6. That's where it crosses. So in fact, what we're doing is finding where the parabola associated with this formula crosses the x-axis. All right, moving along. So next, instead of the equation already being in its conveniently factored form, what we need to do is first factor it, and then we need to find the solutions like we just did. So we're sort of doing 2 times as much work here on this type of problem. The equation starts out not factored. So it says solve for v. If there is more than one solution, separate them with commas. If there's no solution, click on no solution. For right now, you shouldn't see any that say no solution. They should all have 2 solutions. Okay, so we're going to take this quadratic that we just saw, and the first thing that we need to do is to put it into standard form. That's ax squared, so some number times x squared, plus bx plus c. Now, keep in mind, we can replace whatever variable with, you can use v or u or whatever you'd like. So that's our first step, is to rearrange this into standard form. So we're going to need to add 9v to both sides. Then the next step is to identify a, b, c. Okay, that's the ones that are color-coded here. So A is 4, B is 9, and C is 5. You can see that I've got those there. You'll also, for reasons that'll become clear in a moment, need to know what A times C is. So here that's 4 times 5, that's 20. And then the next thing we need to do, hopefully this is a process you're getting more comfortable with, is find our magic numbers. So our magic numbers need to be factors of 20 that add together to be 9, 9 being b. Okay, so you can think of factors of 20, 2 and 10, 1 and 20, and then of course 4 and 5. I think, can those add together to be 9? Yes, they can. They are going to be my magic numbers here. So all I'm doing, if you look, these two equations are identical. 4 plus 5v, that's 9v. And we're just expanding them out so that we can actually do our steps worth of factoring here. And so we've got it in standard form. We've got it with our magic numbers. Those were 4v and 5v. And we'll do the next step, which is to factor by grouping. Okay, so we're going to group the first two terms and the last two terms. So we group the first two, that's 4v squared plus 4v, plus grouping the second terms, that's 5v plus 5, and that still equals 0. Next, we are going to factor the greatest common factor out of both of these. So I can pull both a 4 and a v out of both of these terms because you can see that they both have a 4 and a v. We're kind of undistributing. We'll talk about that in just a moment once we see what it looks like. And then there's a 5 that I can pull out of both of these terms as well. So my 4v comes out on this side, and I'm left with v plus 1. On this side, I have the 5 I pulled out, and left over, I have v plus 1. Now, we're in a good spot here because we can see that we have the same thing inside of our parentheses. That means that we've done things correctly. If you notice that these parentheses contain different expressions, then something might have gone wrong. Okay? So next, we write the factors out. So one of them is going to be the things we factored out, so 4v plus 5. And then the other factor is going to be v plus 1, whatever is in the parentheses. And then those are equal to 0. You'll notice that now we're at the place that we started with the first problems that I showed you. We're in the factored form. Now we need to set this equal to 0 and find what v equals. It should have two solutions. So just like we did before, we'll set this first term, 4v plus 5 equal to 0. Solving for that, we get v equals negative 5 over 4. And on the other side, we set this equal to 0. So v plus 1 equals 0. And just subtract 1 from both sides, v equals negative 1. All right. So from there, we have our two solutions, and we would simply type that in ALEKS. Negative 4/5 and negative 1. Those would be our two solutions. All right. Last one. All right, so take a look at this one. Take a second, see if you can work out what the answers are for this one. All right, welcome back. So we have 2x squared minus 2x equals 4. We need to put it in standard form that looks like this. So in order to do that, we need to subtract 4 on both sides. So that should look like this. Oops. Okay, so negative 2x squared minus 2x minus 4 equals 0. Here we can quickly identify a, b, and c. A times c is negative 8. So we need to think of the magic numbers by thinking of the factors of 8. So here the factors are 1 and 8 and 2 and 4. Is there a combination that we can use there to get negative 2? Yes, we can. We can do negative 4 plus 2. That's negative 2. Okay, so we can rewrite our initial standard form equation using our magic number. So it'll be 2x minus 4, and then we're going to expand out negative 2x to be negative 4x plus 2x, and then minus 4 equals 0. All right, from there, we need to group the terms. So we would group the first two, that's 2x squared minus 2 minus 4x plus 2x minus 4x equals 0. And then we will factor out our greatest common factor. So for this first one, both of these terms have a 2 and an x we can pull out, and both of these have a 2 that we can pull out. So we end up with 2x times x minus 2, and on this one we have 2 times x minus 2. You'll notice, again, importantly, that we have x minus 2 in parentheses for both of them, which means we've done it correctly. So we'll write the factors now. So 2x plus 2, that's one of the factors, and then x minus 2, that is the other factor. Having those set equal to 0 means that we can find our answers by setting each term equal to 0. So on this side we have 2x plus 2 equals 0, and then we simply solve for x. So we end up with negative 1, and on this side we have x minus 2 equals 0, so we have x equals 2 on this side. Plugging those in, we'll have negative 1 and 2 as our answers for this equation. All right, so we'll graph it one more time to wrap things up today. So again, we are looking for where this parabola crosses the x-axis. and this is exactly what we had typed in. Remember, we set it equal to 0, and we found the first one was -1, which is right here. The second 0, or the second solution, was at x equals 2, which is right there. So that confirms what we did on our example. All right, so for today, just complete your e-learning solving by factoring. That should be semester 2 actually, and that should show up on ALEKS when you jump in there. And then also I'm offering some extra credit topics that you can complete, especially if you did poorly or missed any of the early extra topics from earlier in the semester, earlier in the e-learning I should say. You can go back and make those up, and those will sort of erase those old scores. Thanks. Good luck, guys.